Welcome to an tutorial of Proplan YouTube channel. In this video, we're going to have a discussion of this paper of May-June 2025 paper 0625 variant 3. We've looked at the initial part, so we were to look at question 3, where we're going to talk about areas concerning work undone. If you are new here, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. And also you can be able to check the link in the description that's going to take you straight to our Patreon page, where you can access different PDF and different materials that are usually in Proplan. Let's dive in so that we can be able to get started. Now, work and power. In Igcse physics, you need to know how to work out question to do work, power, and energy. So in that case, here we're having a archer who is trying to shoot an arrow and aiming at that particular target. And we are told that the archer pulls back the bow, doing a total of 110 joules of work. Her hand moves a distance of 0.45 meters. So what you're going to realize here, you'll be asked to work out, to calculate the average force. But for you to work out the average force, you need to understand the formula that is used to calculate work. Work is equal to force times distance. So in that case, if you have work is equal to force times distance, it will mean that if you rearrange the formula, you are going to have that force is equal to work divided by distance. Now, in this case, we have the work done to be 110 joules. That is well stated here. And then we have the total distance that was moved, which was 0.45. So in that case, now since the work that was done was 110 joules, it will mean that we are going to divide by the distance, which was 0.45. So if you work it out, you are going to get 240 newtons as the force that was applied to stretch that. Then we are told that the archer released the bow. So remember the law of conservation of energy, which can be asked in an exam, that work energy cannot be created nor destroyed, but it can be converted from one form to another. You ought to understand that also, so that you can be able to answer various questions. So here, elastic potential energy has been converted to kinetic energy. So elastic potential energy will be converted to kinetic energy. So that's why I use the relation that elastic energy is equals to EKE, which is the kinetic energy. And the formula for kinetic energy is a half mv squared, where m is the mass, v is the velocity at which that object is going to move. Then at that particular point, we are going to substitute that into the formula, and then we find the value of v, and in that case our v is going to be equals to 86 meters per second. So that is the speed at which the object moved. Moving further, we are told, explain why the speed of the arrow as it hits the target is less than. So if it's less than, so that means that the kinetic energy is converted to the elastic potential energy is converted to kinetic energy. So we need to realize that not all the kinetic energy will be converted to, not all the mechanical. I think I need to pause here. Not all the elastic potential energy will be converted to kinetic energy, because some of when you stretch a material, the material gets hot. So meaning some of the elastic potential energy will be converted to heat. Number two, some of the energy will be used to overcome air resistance. So in the process, as the arrow is moving, it will be be opposed due to what we call drag. So some of the energy is used to overcome air resistance, some energy is wasted in form of sound, some energy is wasted in form of heat in the process. So the reason as to why the speed of the arrow as it hits the target is less than the value that we have there is because some of the energy will be used to overcome air resistance or drag. We look at also another question to do with conduction. Explain how thermal energy is conducted through copper base. So in this case, something that you really have to put in mind when you are explaining about conduction is the presence of free electrons. So we have free electrons in the lattice, in the structure of a metal. So these free electrons are the ones that are free to move within the structure. In the process, as they move, they are going to collide with other atoms or ions in that particular structure. Then in the process, they will make them to vibrate. And once the material starts vibrating, its energy, thermal energy, increases. So in the process of these free electrons moving, they transfer energy, thermal energy. And also as they move, they collide with other ions or other atoms. Then in the process, increases their kinetic energy. And therefore, energy is transmitted as free electrons are moved. We need also to know how to define the term we need to know how to define the term specific heat capacity, because that's also one area that is highly tested, mostly tested. What is specific heat capacity? Whenever you are asked to define specific heat capacity, we are going to say specific capacity is the amount of thermal energy required to increase the temperature of 1 kg of a substance by 1 degree Celsius. So you need to understand that definition, and also you can be able to be asked to describe an experiment to determine the specific heat capacity. So in that case, let's now dive in and get to see what are the other questions that were asked here. Amount of heat required to increase or raise the temperature, we need to say that. And then specific capacity of water is this, and the mass of water in the insulated cup was 50. The mass of the metal of the object, metal object, was 54 grams. Then we were supposed to calculate specific capacity. So remember, thermal energy that is lost from a hot object is the same amount of energy that is absorbed by the liquid that was at a lower temperature. So in this case, the metal was subjected to a lot of amount of heat. Then it was hot. It had high temperatures. Then that metal was dropped in a liquid. So in that process, the metal will lose heat from the metal will lose heat, but water will absorb that heat to raise its temperature. So if you are going to ask to work out question like that, you need to remember the assumption that we're taking place here, that heat loss is equals to the heat gained. And the heat lost is the heat lost from the metal. So you're going to take 54 times specific capacity of the metal times the temperature change of the metal. Because the metal was having 100 degrees Celsius, so it cooled to 31. So meaning there was a temperature change of 69. Then should be equals to the mass of water times specific capacity of water, and the temperature change of water from 22 to 31 is basically 9. So if you divide by 54 times 69 both sides, because we want to make this the subjects for us to find the specific capacity, then it means we're going to get our specific heat capacity as 0.51 joules per gram per degree Celsius. So basically that's what you are supposed to do in question 4, question 3 and question 4. Then next, now we are going to look at the question of refraction. So check the link in the description for question 5. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. See you the next tutorial.